Today we will solve various type of problem related to atomic structure for JEE Mains and Advanced. Today specifically we will focus on JEE Mains related problems and WBJEE related problems and Neet, and day by day we will increase our potential and we will move forward to advanced level problem. Now see, our first question is the electron transitions from n equals to 2 to n equals to 1, these are principal quantum number, will produce shortest wavelength. Now see, from Rydberg equation we know 1 by lambda, that is nu bar, wave number equals to 1 by lambda equals to z square rh 1 by n1 square minus 1 by n2 square. For hydrogen and hydrogen like species we only use rh, but if it is not hydrogen then we will use z square term also in the multiplication. Remember, this is very important. Here given n equals to 1 to n equals to 2 to n equals to 1. That means initial state. What is the initial state? It is coming from the electron is coming from n equals to 2 to n equals to 1. So n1 is 1, n2 is 2. The 1 by lambda equals to z square rh 1 by 1 minus 1 by 2 square, that is 4. Calculate, you will get this. Now what is lambda? Lambda would be, kindly inverse this thing, reciprocal, that would be proportional to, this is 3 by 4, rh is a constant, Rydberg is a, rh is a constant, Rydberg constant. So lambda would be inversely proportional to z square, that is atomic number. Now they are asking about shortest wavelength. For shortest wavelength, z would be maximum, atomic number would be maximum. So see the option, lithium atomic number is 3, helium is 2, hydrogen is 1, hydrogen is 1. So our option would be lithium, because atomic number of lithium is highest. So lambda would be lowest. Now question 2. In the Bohr's orbit, what is the ratio of total kinetic energy and total energy? Total kinetic energy and total energy of the electron. See, if this is our nucleus, we know charge of nucleus is positive, that is Z into E. Charge of proton is Z into E. And let us say this is our electron stays here, and distance between electron and proton is r. Let us say the distance is r. So it is revolving, that means it should have, electron is revolving, so that means it should have some kinetic energy, that is half mv square. Now what is the electrostatic force? The proton is attracting the electron because charge is much higher than electron. So we know from Coulomb's law, that is, if there is two charge q1 and q2 and distance between them is r, then force of attraction or repulsion is given by k into q1 q2 by r square, where k is 1 by 4 pi epsilon naught. So if we omit this constant term, then Coulomb's force or electrostatic force by which the proton is attracting the electron towards itself would be, see this term we can break it out, is something like this, Jd q1 into q2 divided by distance between them divided by r square. So this is the electrostatic force between proton and electron. Now if this happens, then if proton is attracting electron towards itself, then it should collide with nucleus, but that doesn't happen because it is revolving around nucleus, so it should have some centripetal force, and centripetal force is balanced by centrifugal force. What is centripetal or centrifugal force? That is mv square by r. So this is mv square by r. So this mv square by r should balance with this electrostatic force of attraction. So Jd square by r square should be equals to mv square by r. So from here we can say, see Z square by R into 1 by R equals to mv square by R cancel out. So we see Z square by R is actually your mv square, and potential energy, the formula of potential energy is minus Z square by R. For force it is R square, for potential energy it is only R. So Z square by R comes out to be mv square. So what would be the potential energy? Potential energy would be minus mv square. Now what is total energy? Potential energy, kinetic energy plus potential energy is your total energy. Kinetic energy is half mv square, potential energy comes up to be minus mv square. So half mv square minus mv square would be minus half mv square. They are asking about kinetic energy by total energy. So kinetic energy is our half mv square, and total energy comes out to be minus half mv square. So cancel half mv square half, you will get minus 1. So option A is correct. Let us see some formula which will be used in throughout the atomic structure. There will be some few more formulas we will learn later, but this is the overall formulas used in atomic structure. Energy in any orbit is 12,400 by lambda, and this wavelength should be in Armstrong, and this energy comes out to be in electron volt. Remember this relation if you want to convert from electron volt to joule. So 1 electron volt is 1.6 into 10 to the minus 19 joule. See, the energy emitted or absorbed is for particular frequency. So we can say energy is directly proportional to frequency of the light. So if we remove the proportionality, we will get E equals to h nu. For n photons, this is for 1 photon. For 1 photon it is h nu. For n photon it will be nh nu. Now see, nu is frequency is c by lambda. So this is nh into c by lambda. So after that we can write in energy in any orbit in electron volt is n into 12,400 by lambda. In Armstrong, n is number of quantums. If you compare this energy 12,400 by lambda, this is also same. So if number of photons increases 2, 3, 4, so then we will use this formula. Now from Bohr's theory of atomic model, we know that angular momentum is a constant, that is h by 2 pi, is proportional to h by 2 pi, and for n number of orbits it would be mvr equals to nh by 2 pi. Now remember this velocity equation, velocity of electron in equation, velocity of electron is 2.18 into 10 to the power 6 jet by n meter per second. Radius of nth orbit is given by 0.53 into n square by j, that is atomic number, and this 0.53 is actually your r naught, that is known as Bohr's radius. Now total kinetic energy is minus 13.6 into j square by n square in electron volt. Total energy is minus kinetic energy equals to potential energy by 2. If you see the last problem, we have derived this formula. Kindly see the last problem we have solved. Total energy is minus kinetic energy equals to potential energy by 2. Now time period, what is the time period? Time period, see, if an electron revolves in an atom, so it moves the total perimeter. So what is the perimeter of a circle? Perimeter of a circle is 2 pi r, that means distance is 2 pi r. We know velocity equals to distance by time, so time would be velocity by distance. So time would be distance by displacement by velocity. So what is the displacement here? Displacement is 2 pi r and velocity is v. So 2 pi r by v gives you the time period in nth orbit. Now t is proportional to n cube by z square, t is proportional to n cube by z square, and frequency is, we know, 1 by t, so frequency is directly proportional to z square by n cube. You can use this formula efficiently in MCQs because these formulas are extremely important. See, total number of spectral lines emitted total number of spectral lines emitted if an electron jumps from E1 to E2 or E2 to E1, then total number of spectral lines emitted would be delta n into delta n plus 1 by 2, where delta n is n2 minus n1, higher orbit minus lower orbit. Now lambda equals to h by md. From de Broglie equation we know lambda equals to h by md, and kinetic energy is q into v. Here v is not the velocity, v is the potential at point. Lambda equals to h by md, or we can say lambda equals to h by p, and we can derive this equation also, that lambda equals to h by root under 2m into kinetic energy, 2m into kinetic energy, or just we have know that kinetic energy is q into v, where v is potential. So in this equation, if we put kinetic energy q into v, we will get lambda equals to h by 2m q into v. This equation is also useful. Lambda equals to 12.24 by root under v. Here v is again potential, this is not the velocity, in Armstrong. Here in this equation the result will be in Armstrong. If we see the square root of 150, it would around 12.24. So we can use this formula also. That lambda equals to root under of 150 by v, where v is potential. Remember this. Now if we are given to find out the uncertainty, we will multiply exact value with the accuracy, then we will get uncertainty in the position. Now energy of nth orbit is given by minus 1312 z square by n square, this is in kilojoule per mole, or 13.6 into z square by n square, this is in electron volt per atom. Whatever the problem given, please remember the units. If you want to use this formula, this is kilojoule per mole. If you want to use this formula, the answer would be in electron volt per atom. Now our last problem is, last formula is, when an electron jumps from one outer orbit, that is higher energy. See, if let us say this is n2, this is n1, and that electron is coming from n2 to n1, that is higher energy to lower energy, n2 to n1, then energy difference would be En2 minus En1, which would be 13.6 into z square into 1 by n square, n1 square minus 1 by n2 square, which would be in electron volt per atom. If you want to use this equation for joule per atom, then you have to use this 2.18 into 10 to the power minus 18 z square into 1 by n1 square minus 1 by n2 square. This is the overall, these formulas are extremely important, kindly remember this. Now we will solve some problems related to this. So let us see some problem related to the last slide we have used for the formulas. The first question, if radius of second Bohr orbit of the helium plus ion is this, energy is given, radius is given, what is the radius of the third Bohr orbit of lithium 2 plus ion? Now see, we have just used this formula, written down the formula in the previous slide, that R is equals to R naught into n square by z. This problem came in a recent question, Neet 2022 question, recent question. See, for helium plus ion, n is 2, z is 2, proton number is 2, n is 2, because it is given second Bohr orbit. Second Bohr orbit means n equals to 2, and for helium z is 2. So apply, put the values, you will get, and see the radius is given for second Bohr orbit 105.8 picometer equals to 2 into R naught. So R naught would be 105.8 by 2 picometer, and they need the third Bohr orbit radius. So for lithium n equal third Bohr orbit, so n equals to 3, and for lithium z equals to 3. Apply the same formula again. For lithium 2 plus, it would be R naught into z square by n square by z. So n is 3, so z 3 square by 3. So you will get, and see, we have already calculated out R naught, that is 105.8 by 2. So put the values of R naught, you will get the answer, that is 158.7 picometer. That is option A. See the next question. The frequency of radiation emitted when the electron falls from n equals to 4 to n equals to 1 in a hydrogen atom will be. See, we know for hydrogen atom energy is 2.18 into 10 to the power minus 18 1 by n1 square minus 1 by n2 square in joule per atom. I have already discussed about this formula. So see, the particle is, the electron is coming out from n equals to 4 to n equals to 1. That means this should be n2, this should be n1. So 1 by 1 square minus 1 by 4 square, you will get this joule per atom as the energy. Now we know energy E equals to h nu when u is the frequency, and nu would be E by h. We know the value of E and we know the value of h, that is Planck constant 6.626 into 10 to the minus 34. Calculate and divide, you will get 3.08 into 10 to the power 15 per second. So 3.08 into 10 to the power 15 per second. Option C is correct. These are Neet previous year question. Let us solve some another problem. The question given is, if lambda naught and lambda are the threshold wavelength and wavelength of incident light, the velocity of the photoelectron ejected from the metal surface. See, from photoelectric effect we can say, if this is a metal surface and some light is incidenting on it, let us say this light has frequency nu, and we know in order to eject some electron, first of all the electron, it will absorb some energy to come on the surface, and rest of the energy will be given to the electron for kinetic energy. So let us say E naught energy is absorbed, and frequency, the minimum frequency which is required to eject the electron is, let us say, nu minimum frequency, let us say mu naught, and this is nu. Then we know from Einstein photoelectric effect that this E, the energy which is coming of the light, should be equals to E naught plus this kinetic energy. Now we know E equals to h nu, and for frequency nu naught it should be E naught equals to h nu naught. For frequency nu naught it should be h nu naught, and nu is c by lambda, so this should be h c by lambda naught, and this should be h c by lambda. So we got E naught, we got E. If we take E naught in the left hand side, so E minus E naught should be equals to our kinetic energy. Okay, so kinetic energy is our half mv square, that should be equals to E minus E naught. What is E? E is your hc by lambda. What is E naught? hc by lambda naught. Take common hc, we got 1 by lambda minus 1 by lambda naught. So take LCM, we will get this. So they are asking about velocity, so 2 multiply, cross multiply 2, divide by 2, you will get V equals to something, this equation, which is option C. Let us see, this problem came in JEE 2004-14 and this problem in 2009. In an atom, an electron is moving with a speed of 600 meter per second. The velocity is given with an accuracy of 0.005%. That means accuracy in velocity. Accuracy in velocity is given as 0.005%. Certainty to which the position of the electron can be located. That means they are asking about x, delta x. From Heisenberg uncertainty principle, we know error in position multiplied by error in momentum is greater than equals to h by 4 pi. This is from Heisenberg uncertainty principle. So in place of momentum we can write as m into delta v. So they are asking for delta x, so delta x should be h by 4 pi into 1 by m into delta v, 1 by m into delta v. Now we know h, Planck constant, h 4 pi is 22/7. We know mass of electron is 9.1 into 10 to the minus 31 kg, and velocity, see the accuracy is given, accuracy of velocity is given 0.005%, so it should be 0.005 by 100, and velocity is given, where is the velocity, see 600 meter per second, the speed of electron is 600 meter per second. Put the value, calculate, you will get the answer. The answer is option A. So that's all for today. In the next class we will move forward, we will extend our logic or this lecture towards atomic level, and we will solve more difficult problems. I hope you liked it. Please like, subscribe and comment. Hope everyone is enjoying our lecture. Kindly support. Thank you.